In this lesson, we're going to pick up from where we left off in the previous video, and we'll be looking now at irrational numbers. Now, these numbers are numbers that cannot be expressed as a decimal or a fraction. For example, and I've never really seen a symbol or a letter that represent irrational numbers, so I'm just gonna go ahead. If you can research one, you feel free to do it as a video response, and I'll add it to my video. All right, and giving you credit for it, of course. Okay, but so since I've never seen a letter that denotes irrational numbers, so let's look at some examples of irrational numbers. As it states, numbers that cannot be expressed as a decimal or a fraction. So for example, the square root of 2. Now let me show you quickly why the square root of 2 is classified as an irrational number. Let's just get out our calculator here. Now if you notice, I'm taking the square root of 2, so that's 2, and I'm going to press my square root sign, that's this symbol there. And if you notice here on my calculator, I have 1.41422, and the number continues forever. Okay, it doesn't stop. Actually, it doesn't stop. This is just what the calculator can hold right here. Okay, so we call this number an irrational number because it doesn't stop. There isn't a digit where we can say, okay, it stops at that particular digit. It just goes on and on and on and on after the decimal point. So the square root of 2 is called an irrational number. Let's just look at another exercise quickly. So we have the square root of 2, so let's try the square root of 7. Okay, and let's just grab our calculator quickly again, and let's clear that. So if I want the square root of 7, I'm going to say 7, and I'm taking the square root of 7. And if you look again, it's 2.6 something something something. The number goes on and on and on and on and on. So the square root of 7 is an irrational number. We could take another number as a matter of fact. Okay, now let's look at pi, and don't worry about pi. Pi is a value, a constant that is used when working with the circle. We'll look at that later on in other lessons. Now pi is equal to, you can say, 22 over 7. So let's again take out our calculator and let's type in this number here, 22 divided by 7. Okay, and that is equal to, and look at this number on my calculator, 3.142, and it goes on and on and on and on and on again. So these numbers are examples of what we call irrational numbers, right? They cannot be expressed as a decimal or a fraction. They cannot be expressed as an exact value. All right, good. Now, having said that, let me just close my bracket by looking at just those few examples. Now, even numbers. Even numbers are numbers that when divided by 2, they have no remainder. Okay, so let's just look at some examples of even numbers quickly. Let me use a yellow. So curly brackets. So even numbers are 2. 2 into 2 goes 1. Okay, so 2 can be divided by 2. I have no remainder. I can have a 4, and we can look at it quickly on the side here. Let's just pull this over a bit, and let's just look at this quickly. All right, first number we had there was 2. Now let's say I had 2 apples, okay, and I'm saying how many sets of 2 can I get out of these two apples? I could get 1 set of 2. So basically 2 can go into 2 once. Okay, so 2 when divided by 2 goes one time, leave no remainder. 4, let's say I had 4 oranges, okay, or 4 limes. 1, 2, 3, 4 limes. Okay, and let's see how many sets of 2s, since we're dividing by 2. Since even number when divided by 2, let's divide this by 2. I could get 1, and I could get another set of 2. So that's 2 sets of 2s I can get. So that's what we really mean when we're speaking about even numbers. Any number divided by 2 exactly without leaving any remainder is called or classified as an even number. Okay, so let's finish this. So we would have a 6. 2 can go into 6 3 times without any remainder. We could have a 8. 8 can 2 can go into 8 without leaving 4 times without leaving any remainder. And again, I'm going to put my 3 dots to suggest that it goes on and on in this sequence. Okay, so those are some examples of what even numbers are. They are numbers when divided by 2, they leave no remainder. Okay, let's move on quickly to our next type of number, and in this case we're working with odd numbers. Now, odd numbers are numbers when divided by 2, they leave a remainder of 1. Okay, and let's look at that quickly. And again, I am not aware of any number, or sorry, any letter that is used to denote odd number. So here I'll just move quickly into the examples. So open bracket, and odd numbers starts from 1. Okay, because look at it. If I have, let me change this color. If I have 1 marble, I can ask myself, let's divide 1 by 2. Now, how many sets of 2s can I get out of that? I can get 0 sets of 2s. So I would get 0 sets of 2s. Okay, because 2 can't divide into 1. And how many would I have left over? I would have this 1 left over. Okay, so 2 into 1, 0 times, 0 sets of 2s I can get, and I would have a remainder of this 1 left over. So 1 is an odd number. Okay, so I would have to go up again. I would have to skip 2 because 2 can be divided by 2. Okay, and we have proven that. So 2 is not an odd number. So I would have to move to the next number, which is a 3. Now let's check. Let's say if I had 3 things and I'm dividing in sets of 2s. Now let's check this quickly. I can say 1, 2. Let's divide this into sets of 2s. I have gotten 1 set of 2s out of 3, and I have a remainder of 1. So that's what I mean by an odd number. When divided by 2, it leaves a remainder. If you notice, I have this remainder outside here. And we can look at another example quickly. So let's check 4. Is 4 an odd number? Well, we had checked it up here, and 4 was an even number because 2 can be divided into 4 exactly without leaving a remainder. So 4 wouldn't be an odd number here. Okay, so let's move up. We would move to 5, and we can check it again. Let's check it. We have 1, 2, 3, 4, 5. Now let's check if when we divide 5 into groups of 2s, if we have a remainder of 1 left over. Okay, so here I have 1 set of 2s. Here I have another set of 2s, and when you look, I cannot get another set of 2, so I have a remainder of 1 left over. So how many sets of 2s? 1, 2 sets of 2s, but I have a remainder 1, so therefore 5 is an odd number because when divided by 2, it leaves a remainder of 1. So I would think you probably get the basic idea there. Alright, so we would have to skip 6 because 6 would be an even number. Let's go on to 7, and we could go up to 9, and then I'm going to put 3 dots again. Oh, well, let me put my infinity sign now to suggest also that the infinity sign means that we go on forever. Now that's it as it relates to odd numbers. Let's move on to prime numbers now. Now another set we have here, we have our prime numbers, and prime numbers are basically numbers that has only 2 factors, and these factors are the number 1 and the number itself, the number we're speaking about. Okay, for example, let me go through that again with you. Prime numbers are numbers with only 2 factors. These are the number 1 and the number itself. So if a number has more than 2 factors, it is not a prime number. So let's look at it quickly. Now in our examples, let's check some number. Let's check the first number, the number 1. Now, is number 1 a prime number? Well, it states that prime numbers has how many factors? It has, let me circle this. It has 2 factors, okay? And if you should check what factors, how many factors 1 has. 1 would only have one factor, which is 1 itself. Okay, so 1 is not a prime number. Let me just put a big red X there to suggest that 1 is not a prime number. Let's check the number 2. How many factors 2 has? 2 has, and if you notice here, let's just quickly do it here. We have 1, 2. Let's check out how many factors 2 has. 2 has, how many sets of 2's can I get out of 2? I can get one set of 2 out of 2's. Let's draw another set of 2's. How many sets of 1's can I get out of 2? I can get 2 sets of 1's out of 2. Okay, so this is saying that 2 into itself goes 1 time. Okay, and 1 into 2 goes 2 times. So 1 and 2 can be divided by itself, which is 2, and it also can be divided by 1. Okay, good. So what we're saying here, the first prime number we have is 2. All right, so 2 is our first prime number. Let's check another number. All right, let's check the number 1, 2, let's check 3. Now, can 1 divide into 3? Let's check how many sets of 1's we can get out of 3. That's 1, that's 2, and that's 3 sets of 1's. Okay, we can get out of 3. Let's check again how many sets of 2's can we get out of 3. So I would only get 1 set of 2 out of 3. It's very evident. Okay, and we would have a remainder. So 2 is not a factor of 3. Okay, so we have to skip that. So let's see how many sets of 3's now can we get out of 3. 1, 2, 3. So we can get 1 set of 3's out of 3. So here we got 3 sets of 1's, 3 sets. Let me just write that properly. Here we got 3 sets of 1's, and here I am getting 1 set of 3's. Okay, 1 set of 3's out of 3. All right, so obviously only 2 number can divide into 3 without leaving a remainder, and that's the number 1 and the number 3 itself that we're speaking about. So 3 is a prime number. All right, let's check another number. Let's check 4. Now if you should check 4 carefully, so let's check 4 quickly. Okay, say I had 1, 2, 3, 4 stuff. Okay, now let's divide. Now if you should divide 4 by 1, you would get 1, 2, 3, 4. You would get 4 sets of 1s. So you get 4 sets of 1s out of 4. Okay, let's check again. 1, 2, 3, 4. We can divide 4 by 2. So let's divide it into groups of 2. If I should divide 4 into groups of 2, I would have gotten 2 sets of 2's out of 4. So I would have gotten here 2 sets of 2's, okay, out of 4. Let's check again. 1, 2, 3, 4. Let's see how many sets of 4's we can get out of 4. And I can get 1 set of 4 out of 4. Okay, so 4 can be divided by 3. 4 has 3 factors. It can be divided by 3 numbers. It can be divided by 1, it can be divided by 2, and it also can be divided by 4. So 4 is not a prime number because it has more than 2 factors. Okay, so note now, a number is only a prime number if it has how many factors? If it has 2 factors, only 2 factors, and those 2 factors are the number 1 and the number itself. So since 4 is not a factor, let's say 5, I think you would have gotten the general idea now. 5 would be a prime number. 6, well, 6 wouldn't be a prime number because 1 can be divided into 6, 2 can be divided into 6, 3 can be divided into 6. 6 is not a prime number. Let's check 7. Well, only 2 numbers can go into 7, and that's 1 and 7 itself. Let's check 8. 8 is not a prime number because 8 can be divided by 1, it can be divided by 8, it can be divided by 2, and so on. All right, so it goes up to infinity, and that's it, guys. All right, that's it for prime numbers. All right, bye bye. Thank you. We'll pick up in the next video where we look at composite numbers. All right, bye.